Hello, let's do the New York Times Hard Sudoku for October 4th, 2023. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, we can start with these two twos. They look in. This two looks up, so there's a two here. We also have two fives that look in. That puts a five here. I really don't think there's anything else to find immediately here, so let's move on. I'm noticing this 1, 2, 3 triple. The column needs 1, 2, and 3, and there are 4 places for them. So that's something definitely to keep an eye on to get, like, maybe we'll end up with a 1, 2, 3 triple in this column if we fill any of these with non 1, 2, 3s. So that's definitely something to keep an eye on. Can't do anything yet though. Let's do these two 8s and 7s. They look in here. So 8 and 7 go down here. Oops, 8 and 7. 8 and 7. That's not a 7. This 6 looks in, but it doesn't do enough. Yeah, I'm not seeing anything else to do immediately here. It's too interesting? No. This 1 and this 1 cause a 1 to go in one of these two. So that's going to point up. So what do I mean by pointing? I just mean that this box can only get its 1 from column 6, so the rest of column 6 can't be a 1. So these ones point at column 6, eliminating 1s from column 6. So column 6 only gets a single 1. It's got to give it to this box. So this one points up and says these can't be 1. This one points up, says these can't be 1. So we end up with a 1 over here, which is, it's a thing. These can't be 1 is the important thing we're trying to remember. Yeah, I'm struggling to see anything else to do there, so let's just move on. There's two 1s here. So there's a 1 down here. Anything else repeated? The 5. Oh, this 5 looks in, this 5 looks down, so there's a 5 in one of those two. Nice. These 5s point in the same way those 1s did. So the 5s point up, these 5s point down. So the only place for in this box now for a 5 is here. Let's see, does this 5... Yeah, this 5 is very helpful. This 5 looks in, this 5 looks up. That places a 5 there. That places a 5 there. Let's see how we're doing on 5s. This box... Oh, yeah, nice. These 5s look in, this 5 looks down. So that places a 5 here and a 1 here. Because what happened is we lost one of our 1 corner marks by placing a 5 here. So we want to look in the box for how many 1 corner marks are left. There's 1 left. That means we can place it. It's the only place in the box for a 1. That does put a 1 over here, but also these 5s look down, and this 5 looks in. So that's a 5, and we are done with 5s. Very nice. Okay. What else happened here? I feel like there was something I want to follow up with. Maybe the 1s. Oh, I remember what it was. This 4 here. If you remember, this 4 looked down, it was these 3. Now it's just these 2. So we now have a hidden triple in this box. This is a 4, 7, 8 hidden triple. If you have the same number of, so in this case 3. So we have 3 corner marks that overlap in exactly the same 3 cells. You can't have any escapees. It has to be exactly the same 3 cells. So 3 corner marks in 3 cells, or n corner marks in n cells, right? In this case, it's 3 and 3. Then those 3 cells must have those digits. That's a hidden triple in this case. So we can convert those corner marks to center marks because we have found a hidden 4, 7, 8 triple. It's the only place in the box for 4, 7, and 8. So it must be 4, 7, and 8. So let's bake that in by putting this pair in. It looks like it's 6 and 9. And then this triple in. It looks like it's 2, 3, and 9. It's not a 2. Okay. All right, what else can we do here? Does this 6, 9 pair help? I was remembering this 1, 2, 3 here, but it's still not helpful. I don't know. It feels like we should be able to do something with this, but I don't see it. So let's move on. Oh, now this 2 and this 2 is interesting. because that puts a 2 in one of these two. This placed 5. The 5s around the grid are probably helpful in various ways if we relook at them. All right, so these 2s, they point down. This 2 looks down. That places this 2. Nice. So there's a 2 in these. Doesn't seem to do anything right now. This 8 looks down. This 8 looks in. So there's an 8 in one of these two. That points left. This 8 points left. So there's an 8 up here. Is this 4 and 4 helpful? Not that I can tell. This cell seems to see a lot of digits, doesn't it? Well, it sees 1, 2, it could be 3. It sees 4, 5, 6, could be 7. It sees 8, could be 9. That's more than I thought. This 7, 9 needs to go in this row. It's spread across these 3 cells, though. Is there anything else? I'm looking. I don't see it. Okay. All right. We have the 1s. How about these 6s? There we go. So, the 6 is placed. We have this 6-9 pair here that looks at this. So these 6s look in. The 6-9 pair looks down. So that's a 6. Okay. Does that do anything interesting? Not that I can tell. I guess 6 is up here somewhere for what it's worth. Anything else in this band? I don't see it. I don't see anything else in this band. All right. Well, let's do some vertical scanning and then we'll look for restricted cells. 4. I feel like I already basically scanned this. I don't think there's anything else to find here. Let's keep going. These 2 6s look up, so there's a 6 here. This 8 looks up, this 8 looks in. So does the 4. So the 4 and the 8 join together. Ooh, that's nice. So 4 and 8 look up here, 4 and 8 look in here. So, and these aren't 4 or 8. We need to put 4 and 8 in this box, and there's only 2 cells that can accommodate them. That's called a hidden pair. Hidden pairs eliminate everything else in their cells. So this can't be a 6, otherwise we wouldn't be able to fit 4 and 8 into this box. So that is a 6. And then, I was going to place this 6, but I can't. So there's still 2 left in the box. This is getting pretty limited. I noticed it doesn't have a lot of the corner marks that the column needs. Let's take a look. It can be 1. It can't be 2, 3, 4, 5, 6, 7, 8. 1 or 9 only. Okay. Interesting. Don't know what to do with that. I was looking vertically here. This 2. Yeah, we need a 2 in this column. This 2 takes it out of these 3, so that's a 2. So that's not 2. That places this 2. So we're left with this 3-9 pair here. Okay, what else does this 2 do? So we have 2s here. We have 2s here. We have 2s here. Okay, and that's it. I'm not going to mark this around the corner. I usually don't. It just confuses me. There's only 3 left in this box. It's 3, 4, and 9. Clean up a little bit. All right, what else we got? I was looking at this vertically. I think we're done vertical, but just double check. This 7 looks down, this 7 looks in. So I guess we can say there's a 7 in one of these two. What we're really looking for is to see if we can find another one to make a hidden pair, like we did with this 4-8. Don't see it yet, but it could still happen at some point. I think I already scanned this vertically. I mean, I guess we have the, oh, never mind. We have this triple here. So 1, 2, we need 3, 4, and 9 here. That makes this a 1, 6, and 7 triple. Okay, what's that do? These are 1, 4, 6, 9. Nothing. These are 3, 4, 6, 9. Nothing. All right. So let's look for restricted cells. The easiest way to find restricted cells is to look at rows, columns, or boxes with 4 or fewer digits in them. Like this box is 4 or fewer. It's got 4. We need, and just think about what you need. You need 3, 4, 7, 9, and you just want to see, like this can't be 4 or 7. So this is only 3, 9, and that makes a 3, 9 pair. Found a pair instantly. That's the advantage of looking for restricted cells, is sometimes they match up. So the remaining digits in this column can't be 3 or 9. So I'm just thinking about what that means for this row. I'm thinking ahead. Anyway, let's not think ahead. 1, 4, 6, 7. That's pretty interesting. 1, 4, 6, 7. Huh. Okay, I don't think it resolves. But still interesting. Okay. These are 3, 4, 7, 9. So this is only 3, 4, 7 because it sees a 9. So this has been super fruitful. This 3, 9 felt important. We do know that these two are the same digit, because through the medium of this 3, 9 here, if this is a 3, that's a 9, that's a 3. If this is a 9, that's a 3, that's a 9. So these are the same. So this 3, 9 goes... That means this is 3, 7, or 9 only. I don't know that that's needed, but I'm going to mark it. It actually can't be a 9, so it's 3, 7 only. Is that just what it's limited to? Yeah, it can't be 1, 2, 3, 4, 5, 6. That's just what it's limited to. Anyway, doesn't seem to do anything. Oh, you know, maybe both of these cells seem to see quite a bit. Let's think about this row. So we have 1, 2. We need a 3. That can go here. I'm just thinking about these two. We need a 4. Go in either of them. We have the 5, 6. We need a... No, we can't be 7. We do need an 8, of course, and we can't be 9. Oh, okay. So that's a 4, 8 pair. We're getting a lot of these vertical pairs. So what's this 4, 8 do? Oh, that's interesting. Look what this does. So we have this 4 that looks down, and then we have the 4, 8 pair. It tells us this can't be 4. So this was 4, it breaks the 4, 8 pair. So this 4 looks down, this can't be 4, none of these are 4. So actually in this box, 4 is limited to these two cells. And so that joins the 8s. This is actually a hidden 4, 8 pair. So that can't be 3, it can only be 4, 8. 4, 8 pair, it's going to affect this box, and it's also going to affect this row, but let's affect the row first. So that's a 7. This can't be 7, that can't be 7. This can't be 7, so our corner mark pays off. That's a 7. So yeah, now we know these 3, 9s are all the same, which is interesting. So this is also a 3, 9. Yeah, this is only 3, 9, so that makes a 3, 9 pair in here. So that's a 4. Okay, what else we got going on here? I was gonna see what these were. So we need a 1, 2, and 3. It looks like that's not 1. That's not 3. Okay, so 3's in one of these two. So that points up. This 3 points up. There's a 3 in one of these two. Oops. Does that mean anything for these cells? That's interesting. Let's think about what this column actually needs. But we still need this 1, 2, 3, but it still hasn't come into play. Okay. So we need 1, 2, 3, 7, 8. But these can't be 3. So 1, 2, 7, 8. So this is 1, 7, 8. This is all of them. This is 1, 2, 7, 8. Okay. So maybe not helpful. What else we got? You know, we know that these 3 9s are the same. So it goes here. I wonder if that's just what it's limited to. Because that makes a 3 9 pair. Let's see. This can't be 1, 2. Could be 3, 4, 5, 6. Can't be 7, 8. Could be 9. Yeah, that's a 3 9 pair. So that's a 1. So that's not a 1. Ah, that gives us the 2, 3, and 1 here. That gives us the 2 and the 8 here. All these 3 9s resolve. As I said, they all end up the same. These 2 9s look in, so that's the 9, right? Wow. Yeah, puzzle collapses. Very nice. That was a cool ending. Probably other ways to do it, but that was a fun way to do it. 2 in this box is now just here. That's an 8, 4, 8, 7, 4. This 1, 2, 3 never came in handy. Maybe it would have with an alternate solve path, but let's just, I don't know. I don't just want to think about. How about this row? That's a 7. I need a 1, 3 here. I need a 3 and a 5 here. Not 5. What did I miss? Oh, the 5 was in between them. It's an 8. 3 and 8. Okay, so that 8 tells us the order. Let's do this right. Okay. That's a 6. This is a something. That's a 9. That's a 1. This is a 9, and this is a 3, and we're done. All right. Cool. Yeah, that was an interesting puzzle. I think it came down to finding what was it? This 3 9 pair and this 4 8. This 4 8 pair was super cool because the 4 8 pair eliminated 4 from here, and this 4 was already eliminating 4 from these two, and that gave us this hidden 4 8. I suppose it could have also been seen as a naked 1 2 3 triple if these were penciled, but either way. That was neat. I liked that. The 5s all getting placed right at the start was super helpful, if you saw that. Yeah, there was some good stuff in this puzzle. I enjoyed it. I would have loved if this 1 2 3 actually ended up doing something, though, because it really feels like it ought to. I mean, they do end up there, obviously, but this Tidget didn't get placed till the very end. So knowing it wasn't 1 2 3 is probably going to be difficult in a solve. But anyway, hope you enjoyed this, and if you did, then why not leave a like, subscribe, and a kind comment below.